Hello students, I am Shiv and today we are going to study square and roots. So there are some basic rules which are very important when we are studying is square and roots. So first we understand and learn that formulas and that concepts. After that we solve some problems of the square and roots. So our today's topic is square and roots. So first we learn about the square, and when we learn how to solve the problems of a square, then we learn how to find the roots. So today we learn about a square. So what is a square? What is a square? If a number is multiplied itself two times, then we call the multiplication of that number is a square of that given number. There is one example. By that example I tell you what is a square. So what is a square? If 4 multiply by 4, then it is called as 4 to the power 2. So we call 4 square. Okay, so this is the concept of a square. Now we learn some concepts of a square. So first concept is a square of natural number are called the square numbers or a perfect square. So square of natural numbers. What are the natural numbers? Natural numbers are just counting numbers 1 2 3 dot 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 dot. So square of these natural numbers, 1 square, 2 square, 3 square dot 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 100 square, are called as square numbers or a perfect square. There is one example of this is 2 is a natural number, so it's a square. 2 square, that is 4. So 4 is called the perfect square. Now second concept of square is a perfect square can always be expressed as a product of, this is very important, product of pairs of equal prime numbers. What are the prime numbers? Prime numbers are the numbers that are divisible by 1 and itself only. So we see that 6, it is natural number, so 6 square is 36. So 36 is a perfect square according to our first rule of a square. Then 66 can be written as product of, that means 2 multiply 2 multiply 3 multiply by 3, product of pairs of, there one pair of 2 and one pair of 3. So 36 can be written as product of pairs of prime numbers. So 36 is called a perfect square. Next, a number. It is very important rule, and that rule is very important when we or many students solve the problems of many competitive exams like SSC, bank, SSC CHSL, CGL, SSC, all exams of the SSC. So a number having the 2, 3, 5 or 7 at its units place is never a perfect square. So if any number is given, for example 253, 39288 or 689444442, so if in the question, if it is said to you that it is a perfect square or not, then how you solve? The simple or general method is we find the prime factors of that number and we make the pairs of that prime factors. But this number is very big number, so it takes lots of time. But if we know about this rule, that means any number that ends on 2, 3, 7, 8 is never a perfect square. So I can say just by seeing that problem, it is not a perfect square. It is not a perfect square. And what is the concept behind that? It is not the numbers ends on 2, 3 or 7 or 8 at its unit place is never a perfect square. We can see that if we multiply two numbers from 1 to 9, they never ends at 2, 3, 7 or 8. That is the reason behind that. That means if we multiply 1 by 1, it's 4. 1 by 1, it's 1. 2 by 2, 4. 3 by 3, 9. 4 by 4, 16. 5 by 5, 25. 6 by 6, 36. 7 by 7, 49. 8 by 8, 64. 9 by 9, 84. We see that the ones digit of all these numbers are 1, 4, 9, 6 and 5. There is no ones digit 2, 3, 7 or 8. That is why we can say that any number which is ends on 2, 3, 7 or 8 at its unit place is never a perfect square. Okay, this is okay. In rule number 4, it is said that a number ending in odd numbers of 0 is never a perfect square. Odd number means 1, 3, 5, 7. Okay, test. That means are numbers which are not divisible by 2. So a number ending in odd number of zeros, that means 1 0, 3 0, 5 0, 7 0. A number ending in odd number of zeros is never a perfect square. For example, 20, there is one number of zeros. 2000, there is three number of zeros, and it's a 1 2 3 4 5 6 7. That means 7 number of zero. So there are odd numbers are 0, so they are never a perfect square. Never a perfect square. Second, it is a concept number or rule number 5. It is very easy and well known also. A square of even natural number are even, and squares of odd natural numbers is always odd. For example, 14 square, 18 square, 12 square and 20 square. These are the even numbers. Even numbers, that means which are totally divisible by 2. So square of 14, it's 196. Square of 18, it is 324. The square of 12, it is 144, and square of 20, it is 400. We see that the square of that even natural numbers are also even numbers. Okay, because its unit digit is 0, 4 and 6. So these are also even numbers. So square of odd numbers that are not divisible by 2. So we see that 11, 13, 9 and 29 are the odd numbers. So square of 11, 121, square of 13, 169, square of 9, 81, square of 29, 8, 4, 1. So we see that the square of odd numbers are also odd numbers. Okay. This is rule number 6. Let's see what rule number 6 say. First, if a number has 1 or 9 in its unit place, then its square ends in 1. Why it is? Because if we multiply 1 by 1, it's 1, unit digit is always 1. And if we multiply 9 by 9, the unit digit is always 1. So if any number, it's not matter how much big number, if its unit digit is 1, then the square of that big number's unit digit is always 1. For example, if any exam it is said to you, what is the unit digit number of square of this number? So the student who don't know about this rule, who just multiply 449 multiply 449, but a student who know about this rule, he just say in 1 second that its unit digit is 1, square of that number's unit digit is 1, because of this rule. So next rule, if a number has 4 or 6 in its unit place, then its square ends in 6. Why? Because when we multiply 4 two times, we get the unit digit 6, and if we multiply 6 by 6, then its unit digit is 6. Similarly, like above example, if any exam it is said to you, find the unit digit of square of that number. So you can answer that question in 1 second, that its square of this number's unit digit of square of this number is 6, because you see here that is in this number the unit digit is 4. Next, the third part of 6, it is said that if a number has 2 or 8 in its unit place, then its square end in 4. Why? Because same rule is applied in all these rules. What? When 2 is multiplied by itself, its unit digit is 4, and when there is mistake, when 8 is multiplied by itself, its unit digit is 4. So I can take also different examples for this. If any number like 4, 9, 6, 6, 0 and 2, this is very big number. If anybody asks to you what is the unit digits of number, if we square that number, so we can say, we can reply within 1 second that the unit digit of a square of that number is 2, because the unit digit of that number is 2. Okay, these are the some another concepts of the squares. Here, if a number has 3 or 7 in its units place, then its square ends in 9, because of 3 multiplied by 3 it's 9, and 7 multiplied by 7 it's 9. Okay, all units digit is 9. For example, if any number is 253 and I find the square of that number, then its unit digit is 9, because the unit digit of that number is 3. So the square of that number's in the square of that number's unit digit is 9. Now if a number, it is, these two are the very basics, but they are the rules, so we discuss that. If a number has 5 in its units place, then its square ends in 5. Always, we all know that the 5 multiplied by 5, that means it's a 25, the unit digit is 5. But okay, and if we apply that rule in any big numbers that ends at 5, then its square of that number also end at 5. Now if a number has 0 in its units place, then its square is also ends at 0. For example, it's 0 is multiplied, it's 0, and when 10 is multiplied by 10, it is a 100. So the unit digit is 0. Okay, that's all. Now we learn some interesting and useful facts of square. So there are some. First we discuss the first interesting fact of the square. So the first interesting pattern is there are 2n non-square numbers. 2n non-square numbers between the squares of two consecutive numbers n and n plus 1. What are the consecutive numbers? If there is a number 2, so consecutive number of 2 is 2 plus 1. If any number is given 5, so consecutive number of 5 is 5 plus 1, that means 6, and consecutive number of 2 is 3. So first I take example to demonstrate this rule. So here are the 1 square and 2 square. 1 square is 1, 2 square is 4. So between these two squares there are the two numbers. First is 2 and second is 3. So in this case the n is equals to 1 and n plus 1 is equals to 2. So they said between square of these two numbers there are 2 multiplied by n numbers. 2 multiply n numbers, that means here n is equals to 1, that means 2 multiplied by 1, that means 2. So between the square of 1 square and 2 square there are the 2 non-square numbers, and 2 non-square numbers are 2, 3. There is another example. The two consecutive numbers is 2 and 3. So the value of n is equals to 2 and value of n plus 1 is equals to 3. So between the square of that two non-consecutive number there are 2 and non-square numbers. 2 and here the value of n is equals to 2. So how many non-square numbers between the square of 2 square and 3 square is 2 multiplied by 2, that means 4. 1, 2, 3 and 4. If you find the square of 2, it's 4, and the square of 3 is 9, and between 4 and 9 there are the 2 multiplied by 2, that means 4 numbers are there. Now next example, here the value of n is equals to 5 and consecutive of n, that means n plus 1 is equals to 6. Now square of 5 is 25 and square of 6 is 36. So between 25 and 36 here 2 multiplied by 5, that means there are 10 numbers. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the square of 5 and square of 6, between these numbers there are the 2 and that means 2 multiplied by 5, that means 10 non-square numbers. Okay. This is another very useful and interesting fact related to the square. So addition of first and odd natural numbers is n square. That means here 1 plus 3. How many odd natural numbers? That means n is equals to 2. There are the 2 odd natural numbers. So the sum of these two odd natural number is 2 square. That means 4. Next, how many natural numbers are there? Odd natural numbers are there. There are 1 plus 3 plus 5. That means n is equals to 3. 3 odd natural numbers. So sum of these 3 first. Start this first. That is important. First is important. So the sum of first 3 odd natural numbers is, because there is 3, so it's 3 square, that means 9. Similarly here the n is equals to 4. How n is equals to 4? 1, 2, 3, 4. They are the 4 numbers. So the sum of these 4 odd natural number is 4 square. In this case here n is equals to 1, 2, 3, 4, 5. So the sum of these 5 first odd natural numbers is 5 square. In this case, n is equals to 7. So the sum of these first and odd natural numbers is n square. That means 7 square. That will 49. Next, the sum of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sum of first 11 odd natural numbers is n square. That means 121. So this is also very important. This is also very important when we do some questions of the SSC and bank also, because it is very complicated if we add these numbers one by one. But if we know this concept, then we can tell the answers in very less seconds. So it is very difficult if we add 3 plus 5 plus 7 plus 9 plus 13, but it is some easy if we learn the square of 11. So it's sum of these all 11 numbers, we can tell the answers in just few minutes. Its sum is 121. Okay. Now we learn another very useful and interesting pattern related to the square. So let's study that pattern. The square of any odd number greater than 1 can be expressed as a sum of two consecutive natural numbers. So here is the first number, that is 3. It is a odd number. So 3 square is equals to 9. And 9 can be expressed as a sum of 4 plus 5. How we get this 4? We get 4 by squaring 3 minus 1 and whole divided by 2. And how we get 5? We get 5 by squaring 3 plus 1 and whole divided by 5. There is another example. 7 square. 7 is also odd number. It's 49. It can be written as 24 plus 25. How we get the 24? 24 can be get by squaring 7 minus 1 and whole divided by 4. It's is equals to 24. Another, how we get the 25? If we square 7 and plus 1 divided by 2, we get 25. And how we get 9? This is another example. 9, it is also odd number, and it can be also expressed as a sum of two consecutive natural numbers. 9 square 81. It can be written as 40 plus 41. And how we get 40? If we square 9 minus 1 and whole subtracted by 2, we get 40, and 9 is square plus 1 whole divided by 2, we get 41. So what is the basic concept to find these two consecutive natural numbers? Here, if any number is n, so first number of the consecutive number is n square minus 1 by 2, and second number is n square plus 1 by 2. Okay, this is very important rule.